See, so to understand the given question first, let us try to visualize the given description and the observer. So we have got two parallel rail tracks. So we have got two parallel rail tracks, and train A is moving along the track 1 towards the north with speed 72 km per hour, and train B is moving towards the south with the speed of 108 km per hour. Okay, and I am placing the observer on the ground. Let's see that one more time. I'm placing the observer on the ground, which means all those measurements with of speed and distance made for the trains would be with respect to the observer who is in ground. Therefore, all the measurements are made with respect to ground. So, displacement of train A with respect to ground, velocity of train A with respect to ground, displacement of train B with respect to ground, velocity of train B with respect to ground. Alright. Now, the question says in meter per second. Therefore, we'll convert 72 km per hour into 72 into 5 by 18 meter per second. And therefore, speed of A is 20 meter per second and speed of B is 30 meter per second. Right? So, yes, we do have it. Now, see, we've been asked to find out the velocity of train B with respect to A. How? Let's see that. To understand that portion, first we have to let me just try to get a bit of more clarity on speed versus velocity. So what I mean is, when we say that the speed is 20 meter per second and 30 meter per second respectively for train A and train B, we have not been asked to find out the relative speed, we've been asked to find out the relative velocity, right? So what is relative velocity, or what is velocity? Velocity can either here be expressed as 20 j cap, so I assume that this is along the vertical y-axis, or oh wait, my bad, this should be 30, right? Or it could be 30 along the minus j cap, and therefore velocity would be minus 30. Velocity would be minus 30. So this differentiation is really important. Velocity of A is plus 20 and velocity of B is minus 30. Now when I say velocity of A and velocity of B, what does practically implies? It implies that velocity of A with respect to the observer is plus 20. What does that mean? It means that the object is moving away from it. Plus, it is moving, it is the distance between the observer and the object is increasing, and therefore plus. Alright. Now, velocity of A is plus 20 implies velocity of A as observed from this observer. Since this observer is on the ground, velocity of A is actually the velocity of A with respect to the ground, or in other words, this is relative velocity A with respect to G, or VAG is equal to plus 20. Okay. Now see, this is where the concept comes in. So please make sure you're really patient enough to listen to this a couple of times, write down it, explain it yourself, and then go for the rest of the solution. Okay. So what is VB? VB is velocity of B, which is minus 30. What does VB represents? VB represents the velocity of this train with respect to the observer. And since this observer is on the ground, what actually is VB? VB is velocity of the train B with respect to ground, which is equal to minus 30. We will come back to this, or maybe we'll, let's just explain this now. Now, how come we have this derivation? This understanding. So let's try to spend some time on that as well. When an observer is standing on the ground and is noting down the velocity of an object A, velocity of A as seen from the ground, velocity of A as seen from the ground is actually velocity of A with respect to ground, or what we call as relative velocity, velocity of A with respect to ground, VAG, which is numerically equal to velocity of A minus velocity of G. And since this is ground, we assume that ground is at rest, therefore velocity of ground is equal to 0. And VA minus VG becomes VA minus 0, which is equal to VA. So velocity of A as seen from ground is velocity of A seen from ground, which is equal to VA. Similarly, velocity of B as seen from ground is velocity of B with respect to G, which is equal to VB. Now, what should be the next step? Or what should we be writing next? Exactly. If velocity of A is VA, if velocity of B as seen from ground is VB, what is velocity of B as seen from A? It should be velocity of BA. Velocity BA, what is velocity BA? Numerically it is VB minus VA. But what is VB? Exactly, VB is equal to VBG. What is VA? Velocity of A with respect to what? Velocity of A with respect to ground. Therefore, this is velocity of AG. So, VB minus VA actually represents VBG minus VAG. Can you guess what should be the next one? The opposite of this, which is velocity of A as seen from B is, now let's write it down. What would that be? It would be velocity of A as seen from B equal to velocity of A minus velocity of B, which is velocity of A with respect to ground minus velocity of B with respect to ground. I hope that makes sense. Okay, so when the observer is on the ground, every measurement, every velocity is measured is relative velocity, not absolute velocity, relative velocity, but with respect to ground. And since ground is assumed to be at 0, the relative velocity becomes the absolute velocity. Alright? Now, keeping this in mind, let us try to now solve the question. So, velocity of A with respect to ground is plus 20. Velocity of B with respect to ground is minus 30. In which case, what is velocity of B with respect to A? It is velocity of B as seen from A, which is equal to velocity of B minus velocity of A. What is velocity of B? It is the velocity of this train B with respect to the observer being ground. It is velocity of B with respect to G. What is velocity of A? Velocity of A is the velocity of train A with respect to the ground, with respect to the observer, and since the observer is on the ground, VA is actually relative velocity of A with respect to ground. And velocity of A with respect to ground is 20 plus 20. Velocity of B with respect to ground is minus 30. So this becomes minus 30 minus 20. And therefore, relative velocity of B with respect to A is minus 50 meter per second. Yes, I do see, I do see at least some of the faces which still have doubt. Please watch the this part. Please go through this part. Write it down one more time. Try to explain these things to yourself. Take another example, generate another example, and try to explain that example based on this, this logic, and things will become more clear to you. It will start making more sense. Okay. Right, now coming to the second half of the question, which is velocity of A with respect to ground is 20. Velocity of B with respect to ground is minus 30. Now here, this becomes really important. Velocity of ground with respect to B. This is where I said the question is conceptual. It is not asking for numerical skills. It is demanding how good do you know the subject is. And I would say maybe in the future you can expect a question based on assertion and reasoning from this concept alone. Let's see how. So what is velocity of ground with respect to B? It is velocity of ground minus velocity of B. What does it physically means? It means if an observer is standing now on train B, let's see that one more time. If the observer who was standing otherwise on the ground is shifted to what? Shifted to the train B, which means the observer is moving along with train B. And in such a motion, when the observer observes a point on the ground, let us say some point marked as Delhi, now velocity of ground with respect to the observer, which means velocity of this point Delhi as seen by the person on the moving train is equal to Vg minus Vb. What is Vg? Velocity of ground. Now how do we measure velocity of ground? It is always with respect to ground. What is velocity of B? Velocity of B is again with respect to ground, and velocity of ground with respect to, since the ground is stationary, this phrase is 0. What is velocity of train B with respect to ground? It is minus 30. Therefore, this expression becomes 0 minus 30, which is VGB is equal to plus 30. Tricky and confusing at the same time, I do understand, but that is where patience comes into picture. Make sure you go through the explanation one more time, and I can assure you that things would be much clear, with much more clarity on the concept. All right. So I don't want to take you through the same explanation again, but what I insist you is that you write down this a couple of times, at least a couple of times, and then explain it yourself. And if you have any query, please feel free to write back. All right. Okay. Moving on